one sample test of hypothesis. And so you remember last week, what we did was we were told to estimate the mean amount of time spent on something, or the mean amount of distance traveled, or the mean amount of expenses incurred. And so what one does is, because we don't have time and we don't have money to survey everybody in the population, we end up sampling some of the population, taking the sample statistics, inputting them into a confidence interval. And once we input all of the statistics and all of the information into the confidence interval, we come up with an estimate that says something to the effect that we're 95% confident that the average time spent doing something is somewhere between 32 and 42 minutes, with 95% confidence. And so we understand how the formula is constructed. It's constructed by way of the central limit theorem, probability, etc. So what we do today is we do something somewhat similar. You're going to see a lot of the same numbers. You're not going to see a big formula, but you're going to see pieces of that formula in what we call a hypothesis test. And so today what we're going to do is we're going to test whether or not I'm going to get some shot. So what we do here today is to state a hypothesis, something to the effect that the mean is equal to 32 minutes. And then what we're going to do is we're going to test whether or not that's true or false. And so for hypothesis testing, the answer is going to be either yes or no. True, false, based on what the hypothesis is. And so therefore, when we do hypothesis testing in this class, you have to show me more than just the answer yes or no. I'm not going to accept yes as all the work and as the answer as to whether or not the hypothesis is true, because anybody can just say yes. So you have to show me all of the different steps that one has to take in hypothesis testing. And so what I'm going to do is I'm going to write the steps down over here. And this it's pretty simple. And the first step in the hypothesis test is to state the null hypothesis and state the alternate hypothesis. And so maybe we'll do as an example, it takes 20 minutes to feel better after taking this pill. So we're going to test whether or not that's true or false. Actually, I'm going to change it just a little bit. I'm going to say it takes within 20 minutes to feel better. Okay, so after tonight's class, you'll be able to test whether this is true or false by way of hypothesis testing. And so going back over to here, the first step in the hypothesis test is to state the null hypothesis and state the alternate. And we'll go back over here in a minute to try to write down what we think we're testing over here. The second thing is to select a level of significance. And the level of significance is alpha. What was the level of confidence last week? How was that designated? It was designated 1 minus alpha. correct? So in this case, the level of significance is alpha. And so what kind of confidence levels were we using last week? 95%? 99%? Every now and then 90%. And so when we do hypothesis testing, we tend to use alpha. So we would be using 0.01, 0.05, 0.10. The 0.01 would relate to the 99% confidence, the 0.05 would relate to the 95% confidence, and then the 0.10 would relate to the 90% confidence. So we tend to use 0.01, 0.05, 0.10. Most of the time I use 0.05, 5% level of significance, okay? So those are the three types that we will use. The third step is to take a sample. Of size N, little n. Okay, because once again, we don't have time and money to survey everybody. And so what we do is we select the sample, and, okay, damn it. Yeah. I had it. State the null, state the alternate, select the level of significance, take a sample of size n. The fourth step is to, well, actually, it would be part of the third step. It would be calculate the statistics. So let me get the eraser and erase that. Calculate the statistics. Take the samples, calculate the statistics. The fourth step is to select the test statistic. And for this class, or for this course I should say, we're going to have two types of test statistics. We're going to have a Z and a T. And when do you think you have a Z test statistic? Remember that decision tree that we handed out last week?
Standard deviation.
Remember the decision tree? Everybody had the decision tree I handed out last week? That will tell you whether, if you end up in the Z distribution box, that means you have a Z test statistic. If you end up in the T distribution box, you have a T test statistic. And I'll show you how to do the calculations for the test statistic, Z and T. But you will have to use that decision tree to figure out what kind of a distribution you have. Is it a Z distribution or a T distribution? If it's a Z, then you use a Z test statistic. If it's a T, then you have a T test statistic. The fourth step is to formulate, the fifth step is to formulate the decision rule. With critical values. Formulate the decision rule with critical values. And then the last step, once again, poor management of board space. I'll put it up here. The sixth step is to make the decision. About HO. And the null hypothesis is HO. And the alternate is designated as H1. Okay, so there are 6 steps in hypothesis testing. State the null, state the alternate, or states H sub O and H sub 1. Select the level of significance. Take a sample of size n, calculate the statistics, select the test statistic, formulate the decision rule, and make the decision. Okay? And the way you make the decision is you take the test statistic and you fit it into the decision rule. Because the decision rule, which we're going to see in a second, It's pretty self-explanatory on what you do based on where the test statistic falls. Okay? So, those are the 6 steps. I gave a handout. Did you get the handout? No, you didn't get the handout? Here's the handout. Nope. No, that's from last week. We're going to be using that. This is one for this week. Okay. All right. So everything everyone wants to know about hypothesis testing is on these 3 pages. And so what we're going to do is we're going to go over these 3 pages. And see what each of these steps here means. So the first step, it says state the null and state the alternate. Okay, so if you look at this handout right here on the first page, is every way that you can set up the null and the alternate hypotheses. The first half of the page says 1 population, 1 sample for mu and pi. Everybody see that? Second half of the first page says 2 populations, 2 samples for mu1 and mu2, or pi1 and pi2. Everybody see that? Everybody see that? Okay, what's the name of this chapter today that we're doing?
One sample test.
That's right, 1 sample test it's called. Let's see what it says right here in this textbook. It says 1 sample test of hypothesis. What's chapter 11? You got it. 2 sample tests of hypothesis. So, because today we're doing 1 sample test, next week we're doing 2 sample tests, therefore this week we're just going to be talking about the first half of the first page. Because we're going to be talking about 1 population, 1 sample. Next week, 2 populations, 2 samples. Okay? So today is just the first half of the first page. And, there's some designations down below where it says where HO is such and such, and use the population mean, etc., etc. So, in this hypothesis test, state the null, state the alternate. Here's what we're testing. Is this true? Is this a valid hypothesis? Well, what is this hypothesis right here? It says it takes within 20 minutes to feel better. And so when we're talking about 20 minutes, we're talking on average 20 minutes. And so we're talking about mu in this case. And so we're saying, is mu what? As it relates to minutes, right? Yep, this is going to be minutes. Is mu equal to what? Well, it says within 20 minutes. So what does within 20 minutes mean? It's not equal to 20. You think it's greater than 20? How about less than or equal to? This is probably what is meant by within 20 minutes. Mu is less than or equal to 20 minutes. Everybody agree with that? As being within? Excellent. So, this is what we're going to test. Is mu equal to 20 minutes? Now, it says state the null and state the alternate. Before we find out which one is the null and which one's the alternate, if you were to test this, what's the alternate to this? The alternate is what? Mu greater than 20 minutes, right? Mm-hmm. Everybody agree with that? Mm-hmm. Okay. Okay, so we have the hypothesis that we're testing, and we have an alternate. All right, so now we have to go back over here, and we have to say, okay, which one is the null hypothesis and which one is the alternate? And so, for statistics, very important point as it relates to the null hypothesis, HO. When you test the hypothesis in statistics, you want it set up always this way. That wherever you see the equal piece, that is going to be the null hypothesis. So in this case right here, what we're testing is the null hypothesis. So HO is going to be mu less than or equal to 20 minutes. And so that leaves this one as the alternate. Mu is greater than 20 minutes. Okay? Now, if the question were, it takes more than 20 minutes, how would you designate more than 20 minutes? Well, actually, we have it right there, so that's not the best example. If it had said, it takes exactly 20 minutes, what would be the null hypothesis? It would be mu is equal to 20 minutes. And what would the alternate be? Not equal
Not
to.
equal.
Not equal to. And so for hypothesis testing purposes, which of those two is HO? HO is the one equal to. Okay? All right. So if you look at the handout, in the upper half of the handout, it says one population, one sample. And we look at column A. See what column A is? Where it says mu is equal to some number versus mu is not equal to some number. That would be the alternate, correct? Then you see, as we see in column B, it says mu is greater than or equal to some number. And the alternate would be mu is greater than some number. Oh, no, it says less than or equal to versus greater than. And then in column C, it says mu is greater than or equal to some number versus mu is less than some number as it relates to H1. Everybody see that, how those are set up? So for hypothesis testing purpose, you're always going to have you're going to have one of these. Equal to versus not equal to. Less than or equal to versus greater than. Greater than or equal to versus less than. It's always going to be one of those three. All right? And if you go down the column, you see right below it, it says pi is equal to some percentage versus pi is not equal to some percentage. Okay? All right, so remember that for hypothesis testing purposes, as you can see in the handout, the equality equal to, less than or equal to, greater than or equal to is always the null hypothesis. Okay? And you have to set that up correctly, because what happens down here is that when you get to when you get to step 5 and step 4, what you do is you place the test statistic into the decision rule. And the decision rule is going to be something like this. Well, if it falls between here, you accept HO. If it doesn't, then you reject HO and accept H1. And so what happens is that you say, okay, I'm rejecting HO, and you go back to HO, and you say, oh, okay, this is rejected, and so I'm going to accept the alternate. So if you don't have these set up correctly, you have to get the answer wrong. As shown in the handout, is always in HO. Okay, so our test is always going to be about HO. It may not be what the test is up here, but always HO is going to have the equality, and H1 is going to have the not the equality. Okay, so second step in this hypothesis test. Select the level of significance, alpha. And so we get to select alpha. It can be equal to 0.01, 0.05, 0.10. And so for this case, we'll accept 0.05. So the level of significance for this hypothesis test is 0.05, meaning what? 5 out of 100 times, we're going to have the wrong decision on HO. Meaning 1 out of 20 times, when we say it's true, it's really not. Or if we say it's not true, it really is. Similar to confidence intervals. Remember, when we estimate a confidence interval, we say with 95% confidence between this interval, meaning 5% of the time it's not. It's outside of the interval. Or 1% or not 1% of the time. So you're going to see the same kinds of things here in hypothesis testing as we've seen over in confidence interval construction. And so the, what's the third step in the hypothesis test? Take a sample size n. I don't know, how many people, how many do you want to have sampled here? Let's say we sampled 100. So we take a sample size 100, and what do? We ask them, here, take this pill, tell me when you feel better. Now, better is a relative term, but that's what we have at the moment. And so the 100 people come in, and who says 5 minutes, who says 45 minutes, who says 15, who says 13, who says 28. All this data comes in, and let's say that X bar, what's X bar stand for? The sample mean. We'll say the sample mean came in at 25 minutes. Okay? And another piece of information that we use in confidence interval construction is we've used sigma. If you know what's sigma, population standard deviation. So if you know it, you use it. If you don't know it, then you use S. What's S? The sample standard deviation. Okay? And so in explaining hypothesis testing the first time, let's take the easier approach, and let's say that the sigma is known in this case. Then we'll say sigma is equal to 10 minutes. Okay, so there's our information that we have. What's the fourth step in the decision rule? Select the test statistic. And is the test statistic a Z or a T? And so the way you go about selecting the test statistic is you take out the decision tree from last time. Now the second page of the handout, as you can see at the top, it says test statistics used in hypothesis testing. And so almost anything you ever want to know about the test statistic is on this page. And the first half of the page says what? One population, one sample. The second half of the page says two unrelated populations, two samples. And so because we're in chapter 10, and it's entitled One Sample Test of Hypothesis, today's class we're just going to be looking at the top half as the appropriate test statistic. So, question, is this a Z or a T? How do you know if it's a Z or a T? You get out the decision tree that we handed out last week. What's the first question in the analysis of what kind of a distribution we have, Z or T? The first question is the population normally distributed? Is the population of times to feel better normally distributed? And at the moment, the answer is, we don't know. And so therefore, we take that as a no. If you take that as a no, you go to the left. What's the next question? Is n greater than 30?
Yes.
And is sigma known?
Mm-hmm.
Sigma's known. And so therefore, what kind of a distribution do we have? Z. Z. So we have a Z distribution here. And according to the handout, there are two Z's. There's one that says Z is equal to X bar minus mu sub H divided by sigma divided by the square root. And then on the far right it says Z is equal to, even though it says, it looks like just a minus, you might as well put that in as an equal to. Z is equal to P sub S minus pi sub H divided by the square root of pi sub H times 1 minus pi sub H divided by the square root of n. So if you look at those two Z's, one deals with mu and the other deals with pi. And so in this case right here, are we running a hypothesis test on the mean, or are we running a hypothesis test on the proportion? We're running a hypothesis test in this case on the mean. And so therefore, what's the formula for the test statistic? It's Z is equal to X bar minus mu sub H over sigma divided by the square root of n. And so, what's sigma divided by the square root of n, according to the central limit now? It's the standard error, standard deviation of the sample means. X bar is the sample mean. And so in this case right here, what is X bar? X bar is 25 minutes. Minus mu sub h. What's the hypothesized mean? 20. Divided by sigma. What's sigma? 10 minutes. Divided by the square root of 100. And so we have 5 divided by 1 is equal to 5.00. And for test statistic purposes, it's always good to go up 2 decimal places. All right, so for this hypothesis test, we have a test statistic equal to 5. Okay. Formulate the decision rule. Last page of the handout. Formulating the decision rule is based on how you set up the null and the alternate hypothesis. So in order to do the decision rule, you have to go back over to here, the way we set up the null and the alternate. That will tell you what the decision rule is going to look like. Now the decision rule always is going to have a normal distribution. So what you do is you put in a distribution, and the question is this a Z distribution or a T distribution? In this case, it's a Z distribution, so this is going to be a Z. Okay? And so, as you can see the handout here, there are 3 different decision rules. The first one says, if A, then it's called a two-tailed test. Now, A refers to the setup of the null and the alternate. And if you go back to the first table, the first page, and you look at A, how is that set up? That's set up with mu equal to a number versus mu not equal to a number. And so I ask you, is that the way that this is set up?
No.
Equal to versus not equal to, and the answer is no, that's not it. So that's not the decision rule. This is not a two-tailed test. Is it set up like B? It says B. So what's B? B is less than or equal to versus greater than. Is that how this is set up here?
Yep.
Then yes. This decision rule is set up like B, and it's a one-tailed test. And so here's 0 down here on a Z basis, and so the rejection region, if you look at this this distribution right here in the decision rule, the rejection region is in the right, over here. This is reject HO, accept H1. And if it's here, it's accept HO. So what does this decision rule say? I'll bring it up over here. It says if the test statistic is less than or equal to, I didn't put the critical value in yet. We haven't, I gotta put the critical value in here first. Then accept HO. If not, reject HO and accept H1. So what we have to do is we have to find this. That's what they call the critical value. Okay, so this is a critical value down here. And the reason why they call it a critical value is because this is the value that separates the acceptance region from the rejection region. Very critical. It's going to make a major influence on our decision. And so the question is, what is the critical value? And according to the handout, what is the area in the tail?
Alpha.
Alpha. Everybody see the area? See the little squiggly line in there? Looks something like this. Everybody see that on the handout? And so, in this case, what is alpha? 0.05. So, this is a 0.05 right here. And if this is a z-distribution, and 5% of the area is in the tail, what's the critical value? Well, it's on the right, so it's going to be a plus. Now remember, if we had it set up a different way, where this was greater than or equal to, if we drop down to, if it's set up like C, the rejection region is on the left, and therefore it's a negative critical value. All right? And so, if 5% of the area is in the tail, what's this critical value right here? How do you, if this is a z-distribution, and you know 5% of the area is in the tail, how do you find the value for z?
You subtract it from 50.
And you get 0.4500, right? So this is 0.4500 right there, because that would be 0.450 plus 0.05 is 0.50, right? And so what do? You go into the table, and you look up the closest z to 0.500. And if you look at this right here, it's going to be 1.64, 0.4495, or 1.65, 0.4505. So you can either use either of the two. This is going to be a plus 1.64. Actually, you can probably say 1.645 because that's in the middle, even though it's not exactly right. So that's the critical value in this decision rule. And so we go up here and we say if the test statistic is less than 1.645, then accept HO. If not, reject HO and accept H1.
Where did you get the 1.645 again?
You go to the Z table. Now remember,
Yep.
okay, this is a Z distribution. That means you should be on that table which you're at. 05 is in the tail. Now remember, the way the book does it, the book gives you from 0 out to the Z. So if 0.05 is there, you have to, 0.450 is here. So you have to go into the table and look it up to the closest thing to 0.4500. And if you look up 1.64, you see 0.4495. If you look up 1.65, you see 0.4505. And this is supposed to be 0.4500, which is right in the middle. So if you want to put a 5 over here, that's fine.
Okay.
You could either do 1.64 or 1.165. I mean, in statistics, we try to be as critical as we can because this is a critical value. So you probably should go out another decimal, but the table doesn't go out that far. So we're kind of limited with the table. Excel would give you, exactly what it is. It's probably not even 1.645. It's probably something a little less than that. But this can be used as the critical value, and like I said, it separates the acceptance region from the rejection region. Okay. And so, what's the sixth step in the hypothesis test? Oh, there it is up there. Make the decision about HO. And so basically, what we do is we say, how does test statistic fit into the decision rule?